Hello, now let us solve the problem together. In order to solve this problem, going to use this following formula given in the course book. So assume that you have a function, say f of x, and it is the graph of your function as you see here. You pick 2 points, capital A and capital B on the graph. The x-coordinate of capital A is little a, and the x-coordinate of capital B is little b. So if you are interested in finding the arc length on the graph from point capital A to point capital B, you use the following formula. And this formula, as you see, the lower limit A is the x-coordinate of the initial point A where you start from, and B is the x-coordinate of your final point on the curve, and this is y prime squared, which is the derivative of your function squared. Okay? But in this problem, as you see here, y is defined in terms of x explicitly. One way, of course, to calculate y prime in this problem is to use implicit differentiation, which I do not recommend here. You can also do that yourself after the solution is finished. The calculation will be a little bit more complicated than the one that I'm going to present here. What I'm going to do, I'm going to calculate y as an explicit function here. Okay, so here what happens, I want to make y squared alone, so I divide everything by 27. Then I take the square root, which becomes plus or minus. The square root of 4 is simply 2. Square root of 27, I prefer to write it as 3 square root of 3. And the other one becomes x minus 2 to the power of 3 halves because of taking the square root. Okay, sorry, I forgot to take this 2 away. So here you see that there are two possibilities, either plus 1 or the negative 1. In this problem that you are working here, you see that the y coordinates are 0 and 6 square root of 3, which are non-negative values. Okay, and this function is actually consisting of two continuous branches. So there are not that much surprises for you in this function. You see that you really don't need to work with the negative branch. So if you want to draw the graph of that function, it should be something like this. For example, if this is 2, then you will have one branch going up from here, and there is another branch going down exactly, the negative 1. So you see one point is here, A, and then another point B is somewhere here, because both of them are positive. So what I'm interested in is to calculate this arc length on this positive branch. So we don't need to be worried about the negative sign at all. So my calculation will continue with the positive branch. Okay, so I need to calculate y prime. Okay, so y prime becomes equal to, I start with the positive one, so I have 2 over 3 square root of 3. This 3 over 2 goes down, and then I have 1 unit less as my power, which becomes 1 half. Then this 2 and that 2 are cancelled, this 3 and that 3 are cancelled, so what is left for me is actually 1 over square root of 3 x minus 2 to the power of 1 half. Okay, then what I need to calculate, if you remember, I need to calculate y prime squared plus 1 and then take the square root sign. Yes? So what I do, I take y prime and square it. The right hand side becomes simply 1 over 3, and this one to power 2 simply becomes x minus 2. And then I add 1 to both sides, so 1 plus y prime squared is equal to, I multiply this in and then add 1 to it. So when I multiply here, it becomes 1 over 3x. The other one becomes minus 2/3, but when I add 1 to it, it becomes positive 1/3. And then, of course, I can factor a 1/3 out. And then I need the square root of this expression. And again, be careful, I don't need to put plus and minus because I am working in that branch, yes? Okay, so I can also write it as square root. Okay, now everything is ready. I use the formula. L is equal to the integral from A to B. So what are A and what are B? So A is the x coordinate of the starting point, and B is the y coordinate of the final point. Here, the x coordinate of the starting point is 2, the x coordinate of the final point is 11, and this is what I need to integrate. There is a multiplicative constant, I pull it out, and then I have square root of x plus 1 dx. Okay, so what I need to do is just simply to calculate this definite integral. And hopefully you have enough experience by that now. So what we do, we introduce a new variable. So I would say that let us, for example, take u to be square root of x plus 1. Now I square both sides, and then I differentiate. Okay, and then I need to take care of my new limits. What do I mean by that? These limits that you see are the limits for x. So x goes from 2 to 11. This would then imply that u goes from, if x is 2, I put 2 here, it becomes a square root of 3. If x is 11, I put it here, square root of 12. But I prefer to write 2 square root of 3, which is the same as a square root of 12. Now everything ready, I go back here and I start calculating L. So L becomes equal to 1 over square root of 3 integral, but instead of going from 2 to 11, I go from square root of 3 to 2 square root of 3. Instead of this square root, I put simply u, and instead of dx, I put 2u du. And now if I simplify this a little bit, this becomes 2 over square root of 3. I pull these 2 out, integral, square root of 3, 2 square root of 3, u times 2 is u2 du, and this is a very simple function to integrate because the variable itself u, so this becomes 1/3 u to the power of 3, and I have to calculate it from this limit square root of 3 to 2 square root of 3. Okay, so what I will do, I will absorb these two constants, so I multiply them, so it becomes 2 over 3 square root of 3, and then instead of u, I put 2 square root of 3, raise it to power 3, which becomes 8 square root of 3 to power 3, and then minus, I put square root of 3 here, it becomes a square root of 3 to the power of 3. I intentionally wrote it in that way because my goal is to factor 1 square 3 out so that I can cancel the square root of 3 in the denominator. So let me follow here. So this becomes 2 over 3 square root of 3. I factor 1 square root of 3 out, as I said. So what is left for me? Square root of 3 to power 2 is left here, and 8 is left. Square root of 3 to power 2 is just 3 times 8 is 24, minus the square root of 3 to power 2 is left, which is 3. And now what happens? This is square root of 3 and that is square root of 3 are simplified. So I am left with 2/3, and this number is just simply 21. And now finally 3 and 27 are simplified. 7 is left. 7 times 2 is 14 length units. Okay. So I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.